Sì?
Ok.
Ok. Verrete registrati anche voi, eh?
Sì.
Venite su YouTube così come siete.
No.
Okay. So let's start. And today we'll start describing operators in C++. Okay, so yesterday you have seen how to use references, what's the difference between references and pointers, and we have started to see how it works, the copy constructor, so how to copy objects by using, how to customize the copy by using copy constructors. Of course, we go back to this kind of topics, and but before that, let's start discussing a little bit about operators. So in C++, unlike many other languages, you can actually overload operators. So what is an operator? Operator is a symbol that is used to make an operation between data structures. And typically operators are used for example, summing integers or floating point data. And typically in programming languages, operators are restricted to primitive types. In C++, instead, an operator is seen as a function. And so basically it's possible to customize operators for your particular data structures. Okay? So, as I said, an operator is like a function. And in particular, we distinguish two kinds of operators. Binary operators are functions that take two arguments, and a unary operator is a function that takes one argument. And the syntax is very simple. Basically, the function name corresponding to that operator is just the keyword operator followed by the symbol you want to overload. Okay? And so, for example, suppose you have your own class complex, which represents a complex data structure, and you want to overload the meaning of plus equal for this class, then you define an operator that takes two arguments, the object itself, the complex you want to sum to your object, and returns a new object of type complex. Of course, if we apply operators to predefined types, the compiler does not insert a function call. If instead operators are applied to your own classes, then the function is going to be called. Okay, so for example, if you define an integer a and you do a plus 4, this is translated by C++ in a simple machine instruction, a pair of machine instruction actually. And instead, if you have your own class complex and you define two objects b and c of type complex, then you can apply operators to that. For example, b plus equal to 5 is an operator that sums an integer 5 to a complex. And c equal b is another operator which assigns the value of b to c. And of course you have to write this because C++ doesn't know anything about how to sum complex, because complex is your own class. So this is a typical prototype of a class complex. And you see that I define constructor, destructor, a copy constructor, and then a few normal functions like real, imaginary, module, and then a few operators. The first one is the assignment operator. And this assign operator is very similar to the copy constructor in the sense that the idea of the assign operator is to copy one object inside another one. Then we have the sum operator, which just sums a complex to another complex. And then we have the subtract operator, which does basically the same thing. Okay? And operators can be member functions, like, for example, plus equal, minus equal, or they can be global functions. For example, here we have operator plus, which sums two complex and returns a new one, and the operator minus, which does the subtraction between A and B and returns a new object. Okay, so notice some little difference. The operator plus here just sum complex A with complex B and returns a complex, so a new object. Okay? Instead, operator plus equal sums A to the current object on which this is applied and returns a reference to the current object. So there is some difference between the operator as a member function and the operator as a global function. Okay. In general, operators that modify the object, for example, plus plus, plus equal, minus minus, they should be member functions. So they should be declared as member functions, and of course, they will act accordingly. And operators that do not modify the object, for example, plus, minus, etc., should not be member, but friend functions. Okay, so functions that operate directly on the class from the global point of view. Okay, and of course they create new objects. You have to know that not all operators can be overloaded. For example, you cannot invent a new operator. You cannot take an arbitrary symbol and transform it into an operator. For example, I don't know, you cannot take the dollar and make it an operator, because dollar is not used as an operator in C++. So you can only take existing operators and overload them. Okay? You cannot change the number of arguments, of course. You can only specify their types, but you cannot change the number of arguments. You cannot change precedence. Precedence isn't going to work as usual. So, for example, the star, which is the multiplication, has always precedence over plus. And this happens in all cases, so you cannot change this fact. Okay? Also, the dot is a sort of operator because it's used for accessing a function into a class, and this cannot be overloaded. Anything else can be overloaded. So, for example, one thing you can do is to overload the arrow operator, okay, which is given a pointer reference one of the members of the object pointed by P. Okay, so that you can overload. You can overload the ampersand, which is take the address of something. You can overload the star, which is the reference something, and or multiplication, depending on how you use it. Okay, so there are many things you can overload, and actually you can change the meaning of a lot of different things. Okay, so let's try to analyze how to write a simple operator, for example, plus. And here we have an example of implementation of complex. So let's first look at the header file. Okay, so this is complex. These are a few operators inside. These are a few operators for incrementing, decrementing, and so on. And this is a couple of global operators. This is for summing, and this is for printing on the screen. Okay, so let's look, for example, at this global operator. Okay. Okay, so actually I report here several different implementations. Let's look at the simple one. So this object has to sum two complex objects, okay, A and B. These two objects will not be modified by this operator, so I declare them as cost complex reference. So A is a reference, and this function is not going to modify it. And the same for B. Okay, so they are passed as references, and this is very convenient. So the first thing I do, I create a new object, T, temporary, by copying A into it. Okay? Second, I apply the inner, let's say, operator, T plus equal B, and then I return T. Okay? A more direct way of doing that is to do like this. This means create on the fly an object of type complex by invoking its constructor and by passing two real numbers. The first one is the sum of the real part of A with the real part of B, and the second one is the sum of the imaginary parts. Okay? So this is create an object without any name and return it. Okay? This object is going to be a temporary object, which is created on the fly and later on will be used, for example, for assigning. Okay? So, for example, a way of using it is here. C4 is C1 plus C3, and C1 and C3, of course, are two different complex objects. So what happens here is, first, the plus operator is called. So I'm going to call that function by passing these two objects. That function will create a temporary object. Later on, the assignment has to be done, so another function, which is called assignment operator, is going to be called by passing the new temporary object, and this will assign, of course, this to C4. Okay? Notice that here I'm writing const because I want to be sure that nobody is going to modify this temporary object. There is no need for modifying a temporary object, right? So the compiler should catch if the user writes stupid things trying to modify a temporary object. For example, the user may want to write some stupid code like this. Now notice that in most cases this doesn't make sense, because what happens here is that I call the plus operator by passing two objects. As a result of the plus operator, I obtain a temporary object. And then I'm trying to increment this temporary object. Well, it doesn't make any sense, because the temporary object is going to be destroyed as soon as the expression is completed. So incrementing it has no meaning. Okay? If I write this, then the compiler will not complain, because everything is going to be working correctly. But if I write this instead, the temporary object that is being created cannot be modified. And so an operation like this will create a compilation error. Okay? So the use of const on the return value is a way to try to reduce stupid errors by imposing that the temporary object that is being returned cannot be modified. Okay? Okay. Or notice that these two are ways of doing implementing the plus operator are basically equivalent. This is a little bit more involved because I'm actually creating a temporary object on the stack and then I'm returning it. Okay, so it's a little bit more involved. But it's actually better to use this kind of code because we make sure that this operator and the plus equal operator are basically equivalent. Okay, so basically if we are going to change how the plus equal operator is implemented, the plus operator will change accordingly. So there is correspondence between the implementation of this and the implementation of plus. If instead I just repeat the two implementation, of course, when I change one, I have to remember to change the other. Otherwise, I introduce a bug. Okay, so it's better to try to keep everything consistent. Okay. The assignment operator. Now let's concentrate on the assignment operator. What I said for the plus is of course very valid also for the assignment. So assignment and copy constructor should basically do the same thing or very similar things. And to make sure that this is always true, usually one of the two is implemented by using the other one. So the actual core implementation is one, and the other one is just implemented using the other one. Okay? What's the difference between copy constructor and assignment? Well, if you are creating the variable, it doesn't matter if you write using the parentheses or if you write using the equal, the function that is going to be called is always the copy constructor. Okay? Instead, if the variable to the left is already being created in the past, by assigning it, you are going to call the assignment operator. So the copy constructor is called upon construction, and the assignment operator is called upon assignment, of course. Right? So remember this simple fact. Okay, so this is a walk through the implementation of operator plus, and actually here I'm writing a very stupid implementation of the operator plus, and let's see why this is not good programming style. So first of all, I'm not using constant reference as parameters, and this means that a copy is going to be done for the first one and the second one. Okay? So here let's walk across the implementation. So we have 7 function calls involved. First of all, C1 and C2 are copied through the copy constructor into A and B. Then Z must be constructed. Then Z must be copied into a temporary object. Then the temporary object is assigned to C3 by calling the assignment operator. And finally, the temporary object is going to be destroyed. So we have 7 function calls for just implementing this simple sum. We can reduce, of course, some of them by using constant references. So if we just copy the addresses, there is no need to copy the entire thing, and so we saved at least 2 function calls. The temporary is useful because at this point the compiler does not know what is actually happening, so how the complex is going to be used. Maybe it's going to be used as one element of a very large expression, or maybe it's going to be assigned immediately to another variable. So if it is going to be assigned immediately, maybe the temporary is not really necessary. We could do some kind of optimization. However, if instead this complex is going to be used in a large expression, then a temporary is necessary because the new object has to be maybe passed to another function call. Okay, so we cannot know, okay, how to do that. These two ways of writing, so writing this, so you create a complex temp and then you return, or writing this, it's actually, in most of the cases, automatically optimized by the compiler. So if you write this, for sure the compiler is not going to do anything strange. But also if you write this, in most of the cases, there is no extra copy. So the compiler will automatically optimize everything and just create and return the same temporary object. Okay. As I said, there are a lot of different operators, and there are a few that are quite strange. And in particular, new and delete are two keywords that can be overloaded. So they are considered like operators. And in particular, they can be overloaded if you want to define a custom memory allocation strategy. So basically, if you want to change the way you allocate memory for your own program, instead of using the standard new, you could overload new for your own classes and use your custom allocation. For example, in embedded systems where memory is very important, this is quite useful. You can customize allocation for your own classes. But sometimes also when you want to really optimize performance, and you know that for your own object you have a smart way of allocating memory, then overloading new may be a good idea. Okay? Then you can overload the square parentheses. Square parentheses are used, for example, for accessing arrays. Well, you can define your own parenthesis for accessing elements within your own class. And this may be useful when you are going to create a class that is actually a container. In that case, you want to access the different elements in your container. This trick is used, for example, in the standard library for vector, list, and things like that. You can overload the comma operator. And the comma operator is actually maybe useful if you want to write very funny programs, but in general is quite ignored most of the times. And you can overload the arrow operator, and this may be useful for implementing smart pointers. And in fact, this is another trick used in the standard library to implement smart pointers, like unique pointers, shared pointer. We are going to see that later on. And this is, for example, a way to overload operator parentheses. For example, a typical prototype is like that. You are going to use an index to access elements inside the class. Okay? And as an exercise later on, we are going to add this operator to access elements inside stack. We can overload new and delete, and this is actually one way of doing that. For example, we can overload operator new for this class and operator delete. And so every time we call new for this specific class, new will return a memory block where the class is going to be created. Okay? And actually, you can also overload the global version of new and delete. As I said, we can overload star and arrow, and not only for smart pointers, but also for iterators. And again, we are going to see what iterators are in the next lectures. Okay? And so this is, for example, one way of doing that. An operator star is actually applying it to this object of type iter will just return one object. And instead, if you apply operator arrow to this either, this will return a pointer to an object. And this is a pointer that will then be used for calling some function. It's possible to overload these two operators, and less than, and greater than, okay? These are actually also been seen as angular parentheses. And this can be useful when you want to output an object on the terminal. So the classical way of overloading this operator is like this. You use an ostream, and ostream is the base class of cout, scene, things like that. It's actually cout and cr, sorry. And you specify which object you want to output, and then you write how to actually output this. And so let's see how we do that in complex. Here we go. So overloading this, and we pass an ostream and then a complex, and we return a reference to an ostream. And basically O is our stream, and we output a curly brace, then the real value, then the comma, the imaginary value, and then closing parentheses. And then we return this. Why we return a reference to ostream? Well, we return a reference to ostream so we can chain the operator. For example, if we want to do this, okay? So this is calling that operator first on the string. Then the result of this is going to be again cout. And so we apply this operator by passing a complex and cout. And the result is again cout. And then we call this operator by passing endl and cout. And the result is again cout. But now the expression is over, so the last cout is not used anymore. Okay? So for chaining this operator, we are going to use this trick of returning a reference to the stream we just modified. Notice that I'm not writing const here because I'm actually modifying the stream. I'm outputting on the stream, so I cannot specify const. And actually we do the same trick also for operator plus plus, for example, because maybe we want to chain operator plus plus with other operators. For example, I may want to write something like this, right? So basically I'm summing x and y, sorry, I may want to say this, right? So this is actually equivalent to first calling the plus plus operator on x, and the result is going to be the same object. And then I'm going to apply plus plus to y, and the result is again is going to be the same object. And then I'm going to apply operator plus, the global one, on the two resulting objects. Okay? So chaining is important. Notice that I'm chaining operator plus plus, this one, and I'm not chaining this other one. So what's the difference between these two? The difference between these two is that the first one is a prefix, so it's actually plus plus a. And the second one is a postfix, a plus plus. So what's the difference between prefix and postfix? Well, prefix means I first increment, and then I use the value in the following. So basically I modify the object, a, and then I use its value. So I return a reference to the same object that has just been modified. Operator plus plus instead needs to modify the object, but the value returned is actually the old value of A. So this one is returning a new temporary object, which is actually the old value of A. So let's see how it works. So this is the prefix, and this is the postfix. The prefix, it just increments the real part and returns itself. Okay? So if I write something like plus plus C1 dot real, what happens is that the plus plus operator is called on C1, the result is the new value of C1, and then I invoke real on this new C1. Okay? Instead, this one is quite different, because what I'm doing is I'm going to return the old value. So what I do is I first do a copy. Then I increment myself, and then I return the copy. So the result of this operator is a new object, a copy. And so if I write C1 plus plus dot real, what I obtain is the real part of the old value, so of the copy. And C1 is modified afterwards. Okay? So pay attention to this kind of things. By the way, what is this int here? Well, this int is nothing. It's just a syntax for specifying, for distinguish the prefix from the postfix. So actually, this kind of argument is not used. So it's not a very nice thing to do. Maybe they should have taught some very specific syntax for specifying the two, and instead they decide to use this trick. So it's something you should know. If you want to overload the prefix operator, you write this. If you want to overload the postfix, you write that. But this int parameters is actually not used.
It's not a binary operator.
No, this is a unary operator.
A unary, okay.
It's always unary. This int is just a sort of hack into the compiler to just tell and distinguish the two. So it's not very nice, but they did not have many choices on how to implement this. Okay, of course the same is true for the minus minus operator. So the minus minus operator works in exactly the same way. Okay, actually it would be better, again for consistency, to write this in a different way. This means to implement this operator, you first do a copy, and then you call operator plus plus on this same object. Okay? Actually, since operators are functions, you can write them in the two different ways. So, for example, in main, I can write this, but I can also write this. These two ways of writing the plus are equivalent. The first one is implicit. The second one is explicit. Here I'm explicitly calling a function. Okay? And also the assignment, I can do the same thing. If I want to do this, I just do so these two ways of writing the assignment are perfectly equivalent. Of course, there is no point in using the second one, except when I'm forced to do that because I have no other way. So here I'm saying implement the post-fix operator in terms of the prefix operator. And so if I, for some reason, decide to change the implementation of the first one, the second one will change accordingly. Okay? And of course, I can also write in a different way. For example, I can write this. This is also the same way. So these two ways of writing are the same. Okay? Remember that this is a pointer to the current object, the object that is being used in this member function. Okay? So by dereferencing it, I obtain an object, and by writing this, I'm applying the operator on this object. A more direct way, of course, is to do this. I take the address of the current object, and I call that member function on that object. Okay? Okay. Okay, the example here on how to output a stream. It's basically the same as I've shown before. Okay, very quickly about inlines, and then we go to our example with the stack. So inlines. Performance is important. Actually, what is the difference between C++ and many other languages? Well, C++ is chosen most of the times because it's very performant. And I would say that the difference between C and C++ is that sometimes you as a programmer, sometimes you can be smarter than the compiler, and so write very efficient code in C, which is more efficient than C++. But most of the times the difference is so tiny, or sometimes the compiler is so smart that there is no difference at all between C and C++. Okay? So C++ is really fast. And unfortunately, it's also very complex. So if C++ programming were not so fast, probably nobody would use it because C++ is a very complex language. And instead, by knowing C++ mechanisms in depth, it's possible to optimize a lot. So for example, I just explained to you that you can overload the new and delete operators. And this is quite nice because you write your program using standard new and delete. At some point, you understand that memory is going to be your performance bottleneck. And so you just overload new and delete, and you obtain huge performance gains. So you can really optimize to the least bit of code. Okay? And one possible optimizing feature is to specify functions as inlines. And okay, you just write inline in front of the function, and you have to put the code directly into the HTTP file. So for example, candidates for inlining are for sure real, because it just returns a number, and imaginary, and module, because it's just a very simple expression. Okay? Maybe more complex things, maybe it's not the case of optimizing that, so I'm not specifying that. When the compiler sees inline, it tries to substitute the function call with the actual code. So it's a sort of code substitution, code expansion. Okay? And so every time you see real, which is a function, it will just be substituted by the member variable real. Okay? So we save a function call. Typically in C, in the old C, this was done through macros, but macros are quite bad, and it's better to use an inlining because the compiler can really optimize a lot. Of course, the code for the inline function must be defined in the header file, otherwise there is no way of doing that. because this kind of inlining is done by the compiler, not by the linker. Okay, I guess you are all you all know the difference between compiling and linking, right? Has anybody has any doubt about that? So compiling means you take one single C++ file and you produce an object. And then after all these objects have been produced, they are put together by the linker. Now the compiler looks only one CPP file at a time. So if the implementation is in the header file which is being included, then it can make this sort of inlining. If the implementation is in another CPP file which is not being included, and so the compiler knows nothing about that, then of course this expansion cannot be done. And for sure the linker is not going to expand anything. Okay? So if you want to do inlining, you have to specify the code directly into the class declaration. And so also this means that you are exposing some of the implementation in the header file. Now sometimes when the code is quite complex, the compiler will refuse to make inline function. So the keyword inline is actually a suggestion to the compiler, but the compiler is not obliged to inlining. Most of the times it will do its best for inlining, but it's not always the case. Okay, so this thing I'm going to say now is valid for inlines, but it's by the real engine. Okay, and this is a famous sentence by Donald Knuth. It says that premature optimization is the root of all evil. This means when you are going to write any kind of algorithm, the first time you write it, try to be as simple as possible. Do not try strange things, just try to implement the algorithm without any optimization. After you are sure that your algorithm is working, for example by running a lot of tests, then you try to understand where is the performance loss. So you go in the code, you look, you try to see which part of the code is slow and which one can be made fast by reducing maybe some copy, by implementing something in a slightly different way, and so on and so forth. And then you just optimize. If instead you try to optimize since the very beginning, then you are going to introduce very nasty bugs that then are very difficult to find later on. So first try to be simple, try to make it work, then you execute, you measure the performance, and you optimize. So premature optimization is the root of all evil. Okay, so we make a break, 10 minutes, and then we come back in 10 minutes. Okay?